Hello everyone, I will be going through the extensive exercise questions as well as the challenge questions on the half area model lesson. So without further ado, let's get straight to it. Now our first question is, a point is lying somewhere inside a triangle and is joined to the 3 vertices and 3 midpoints lying on each side, thus creating 6 triangles as shown. The area of the big triangle is 24, and the area of triangles A and B are 3 and 5 respectively. What is the area of triangle C? So this question is actually very simple when you think about it, because we can split this bigger triangle into smaller triangles, into smaller 3 triangles like so. And what we will find is that the shaded part of each of these 3 triangles, okay, is always going to be a half of the total area of the triangles. Okay, so in other words, we know that the shaded area is exactly a half of the total area of the big triangle. Okay, because you can see that in each triangle you are indeed seeing a half model that we looked at in the lesson. So we know that the area of A, B, and C has to add up to 24 divided by 2. We know 24 divided by 2 is equal to 12. So we know to find out C, well, we know that A plus B plus C has to equal 12, all right? So we know 3 plus 5 plus C has to equal 12. So very simply, C is equal to 4. Okay, so the area of C is going to be 4 centimeters squared. All right, so that is the first question done. Let's go on to the second extensive exercise question now. Okay, so the second extensive exercise question states that 2 identical rectangles are put together to form a larger rectangle ABCD with an area of 40 centimeters squared. Given that the area of the triangle ADM is 4 centimeters squared and the area of the triangle BCN is 2 centimeters squared, calculate the area of the quadrilateral EMFN. So we want to work out the area of this quadrilateral over here. Now, if we look at both of those rectangles individually, we see that each rectangle is divided into 4 triangles, and we see that in each of the rectangles we have spotted half model. Okay, so in each of the rectangles we have a half model, which means that the shaded area is a half of the total area of each of the rectangles of the rectangle. Okay, so for example, if we're looking at ABCD, the big rectangle, that has the area of 40 centimeters squared, and we know the shaded area, the total shaded area has to equal 40 divided by 2, which is equal to 20 centimeters squared. So that's going to be the area of the total shaded triangles inside the big rectangle. Okay, now we've been told that ADM is equal to 4 centimeters squared, and we know that BCN is equal to 2 centimeters squared, and we know that 4 plus 2 plus the area of the equilateral EMFN, all right, over here in the middle has to be equal to 20 centimeters squared, all right, because that's, you know, we've spotted the half model inside this big rectangle. In other words, we know that the area of EM, F and N is just very simply going to be 40. Okay, so remember guys, you know, that you look at each of the rectangles and you spot these half models, half area models that we looked at in the lesson. Okay, brilliant. Let's go on to the next question. So question number 3 is actually very similar to the question that we did in lesson as well. So hopefully lots of you got this one correct. So as shown below, except for 4 vertices of the larger square, every point is the midpoint of the line that it's located on. What fraction of the biggest square is shaded? Okay, so we know that the area of the new square is actually formed by connecting the midpoints of 4 sides of the square. And what we can conclude from that is that each time the area of the square inside the bigger square is always a half. So for example, if I just look at the smaller square over here, I can split the square into 2 kind of rectangles over here, and we see that we're actually seeing 2 half models, which means that the shaded area of this square over here is exactly a half of, let me change the color so you can all see, it's exactly a half of the square around it. Okay, so each time it's always going to be a half. All right, so now that we know that, let's just say the area of the smaller square is 1. If we know that's 1, we know that the area of the green square around it is going to be 2, because it's going to be double that. And we know that each time the area of the new square, because it's formed by connecting the midpoints of 4 sides of the square, it's always going to be double what we have. So if that's 2, then we are indeed going to have 4. Okay, then we're going to have 8, then we're going to have 16, and then we're going to have 32. And then they want the fraction of the biggest square that is shaded. So that very simply is just going to be 17 over 32. Okay, because 32 is indeed what the total area that we have is out of. Okay, so hopefully that makes a lot of sense, guys. And let's get straight on to our extensive challenge question number 1. Okay, so our extensive challenge question number 1 has simply stated that the diagram has shown 2 triangles inside a rectangle, and the areas of some of the regions are indicated in the diagram. Find the area of the shaded triangle. Okay, so from this and using the half area model, we should be able to see that the area of all of these triangles that we have over here, so we've got 5, we've got 3, we've got 4, is equal to the shaded triangle that we have. So we know that 3 plus 5 plus 4, of course, is 12, okay? And we know that that very simply is going to be equal to the shaded triangle. So shaded triangle area is also just going to be 12 centimeters squared. Okay, looking at what we've just learned. And finally, let's go straight on to our final extensive exercise challenge question, which is actually to do with the overlapping area that we looked at in the lesson. So over here, as shown below, we know that ABCD is a square, okay, and the area of the shaded regions have been marked in the diagram. Now they've just asked us to calculate the area of equilateral BMQN. Okay, so let's first establish what we learned in the lesson. Okay, we know that the overlapping area is equal to the area not covered. Okay, so we know the overlapping area is equal to the area that's not covered. So actually, let's see what's overlapping over here. And I'll do that in yellow so that you'll be able to see very easily and very clearly. Okay, so over here, we've got this triangle. AND. Okay, that is overlapping with DCM. Or DMC for that matter. Okay, so we've got our two overlaps over here, and we have to work out the area of the equilateral BMQN. So we're trying to work out this equilateral BMQN over here. Well, because we know that the overlapping area is equal to the area that's not covered, okay, we're very simply going to have to do 51 minus what's not covered, which is 15. And we've also got 12 over here that's not covered, okay, and that would give us the area of BMQN, which is just 24 centimeters squared, because we know that BMQN plus 15 plus 12 has to add up to 51, because that is our overlapping area. So remember, guys, the trick for this, the last extensive challenge question was to know that the overlapping area is equal to the area that's not covered. So first, label what's overlapping and what's not covered. And once you've identified all of those, then you just need to know to find out the missing not covered area. You just have to subtract from the overlapping area. What I'll do over here for you all is just kind of mark what's not covered in green so that you're able to see very, very easily. Okay, so over here we know that that 15 plus 12 plus BMQN had to equal to 51 centimeters squared, which was indeed the overlapping area. So our answer is 24 centimeters squared. So I hope that you guys have have learned something, and I hope that you've enjoyed all of the questions that we've looked at today, and I shall see you all very soon.